All right, we're back. We're still on page 8 of notes 13. We're on the very last question, and it's a review problem, and it looks like it's about things. Mean value theorem, find and classify critical points, candidates test. Okay, and also, we're definitely using a calculator. So f of x is this quadratic thing times arcsine of x over 3. Find all values of c guaranteed by the mean value theorem applied to f of x on its domain. So what is the domain? Well, this is just a polynomial, so the domain is all reals. So the issue is coming from arcsine. By the way, this calculator question, so like you don't really need to do this analysis, but I think it's a good like thought exercise or something. Arcsine by itself, if you have the sine inverse of u, it's kind of like bleeding into my previous answer. The sine inverse of u, the domain would be -1 to 1. So if you have -1 x over 3 to 1, that's going to give you -3 to 3. So our interval is -3 to 3, and so we can work with that, right? So we're going to look for, let's start it off, right? Find all values. So f of x is continuous on the closed interval, so -3, and differentiable. So this is a good answer on -3, which, like, why are you not doing good answers all the time? So continuous on the closed, differentiable on the open, therefore by MVT, f prime of c equals f of 3 minus f of -3 over 3 minus -3 for some c that's an element. I'm going to say this, c is an element of, I'm doing this strictly for space reasons. There we go. All right, calculator. So we're going to store the function and kind of go from there. So let's see. Share a calculator. I'll do a new problem, doc 4.1. f of x is the quantity x squared minus x minus 2 over 5. And then arcsine is in the trig. I'll use that button. Trig button, 1 down, arcsine of x over 3. Okay. So what are we doing? I'm going to like just do it in one shot. Well, I'm going to try to. I'm going to do menu 3, 1, because I want to solve something. The derivative, so template derivative with respect to x of f of x equals f of 3 minus f of -3 over 3 minus -3. And then comma, x is a variable. Now I should specify the domain, I guess, but let's just, the domain is really finite, so this might have been a bad idea. Oh no, I think I crashed my calculator and I don't want to restart the video, but I also don't want to make you wait. Okay, you know what I should have done? Should have done it graphically. So I'm in the middle of waiting for this to crash. Let me see. I'm gonna go back to the notes here for a second, if I can get back, while I crash the calculator. And do it. Just quit. So annoying. It's like, it's pretty good. And let me try force quit. I'm just gonna make you watch all this because I do not want to start over, so I apologize. Force quitting. Okay, it force quit. So now I'm gonna reopen it. So let's take a tour of the notes while we wait for that. We've done a lot, right? Like solve some differential equations. Don't forget to solve for c. Don't forget to put c when you have those. And then, Inspire's almost open. We did these, the weird u substitutions. So weird u substitutions are definitely like, you recognize it when you need it. Radicals in particular tend to cause the weird substitutions to happen. And then some natural logs. When you do the natural log, when you integrate and get a natural log, integrate and get a natural, oh man. Also, the calculator opening is really messing up the camera work. When you integrate and get a natural log, you definitely want to put an absolute value around it. I don't know, I feel like this is all the things you got to memorize. Where's the one I messed up really badly? Oh, right there, part E on this one. That's the worst I've done so far. All right, I think the calculator's good to go. Let's go back. I'm gonna share a calculator page with you. I apologize for the technical difficulties. So I'm not gonna use solve on this. So f of x is the quantity. So what do you do when that happens? Well, when it happens on your handheld, which will happen, and maybe I wrote this question for that to happen. Like, if I know myself, I definitely did. When that happens on your handheld, hold escape until eventually the calculator will just be like operation broken or break or something. And then you can try a different approach. The different approach that you're going to try is definitely graphing. So what I'm going to do is I'm going to add a graph, and then I will graph the derivative. So I'm graphing the derivative with respect to x of f of x. And then I'm also going to graph f of 3 minus f of negative 3 over 3 minus, I could just do 6 there, but whatever. We get those. Now I'm going to do menu 814. Click, click. Whew. Man, it's like the graph will save you when that happens. I like to zoom box so that they're a little less overlapped. I mean, they're still like crazy overlapped. Okay, so this has given me two different C values. So I'm going to say, therefore, C equals, and I'm just going to write those down. I don't know if you remember what problem we're doing. Therefore, C is approximately, put them in order, like smallest to greatest. If you're a caring, compassionate person, you will do that. C is approximately 2.301. 2.301. Okay. So I was going to say so far so good, but like, no, not really. The next question is find and classify all the critical points of f of x on the interior of its domain. So what I'm going to do is I'm going to add another graph page, and I'm going to regraph the derivative. And I'm going to add the graph of 0, right? Because this is the graph of the derivative. So where the derivative is equal to 0 or undefined, it's not undefined anywhere. So where the graph is 0 are the critical points. The easiest way to find them graphically, add 0, and then do menu 814. Could be menu 813, depending on your calculator. There. I'm going to zoom box around it so that it's like clearer what's happening, because we don't really need to see everything. Okay, so I have my critical points. I'm going to write those down, and you can see what's happening. So critical points. X is approximately negative 0.551. X is approximately, I'm on top of it, 1.236. 1.236. Now what I'm going to do to make my life a little easier, because the next question is about the candidates test. I didn't finish the problem, by the way. F prime changes a positive to negative at this point. So this must be the x coordinate of a relative maximum. And F prime changes from negative to positive at this point. So this is the x coordinate of a relative minimum. I'll write those in a second. What I'm going to do, because the next question is about the candidates test, and so I need to plug these into the original function, I'm going to store them. So I'm going to store this as A, I guess. And then I'm going to store this as B. And that way I can just use those on like the calculator page. All right, so the first one is a relative maximum. The second one's a relative minimum. Let's go back to the notes and write that. So going back, I wish there was I don't know, like a macro or something I could use that would like pop me back and forth. That's probably too advanced, but f of x has relative max at x is approximately negative 0.551 because f prime changes, or f prime of x changes positive to negative there. And then f of x has relative minimum at x is approximately 1.236 because f prime changes negative to positive there. Okay, so hopefully I got those right. I'm pretty sure I did. I can like picture it in my mind that the derivative looked like kind of like that. All right, use the candidates test to determine the absolute maximum, absolute minimum values of f on its domain. So the domain is -3 to 3. We need to say f of x is continuous on -3 to 3. Therefore, by candidates test. So I like to write this out because I think you should. Absolute max. You can do max / min at endpoint or critical point. All right, and we found all of those. So make our table x, f of x, -3, and then our critical points were -0.551, 1.236, and then 3. All right, back to the calculator. We're gonna plug those in. Remember, on the calculator, we stored those values as A and B. So this is A. If you hover over it, it'll tell you what it's linked to, and that's B. So I'm just gonna put in another calculator page. In the same problem, I'm gonna do f of -3. Okay, let's get decimals. F of A, and remember A is this. F of B, and B is this. And then f of 3. I'm gonna put in a decimal to get a decimal back. So let's copy these values. So -3.142. I mean -pi, but 0, that's really small. 0.042. -0.145. And then 1.257. Okay, so once you have all the values in the table, the absolute maximum is the biggest y value that you have. The absolute minimum is the smallest y value that you have, because it has to have an endpoint or a critical point, and you made a table that contains all of the values of the endpoints and the critical points. So the absolute maximum will be at this endpoint, and the absolute minimum will actually be at this endpoint. So therefore, the absolute max is 1.257, which occurs at x = 3. I always put that just because sometimes it asks for the x coordinate, sometimes it asks for the y coordinate. And like, I always try to read the problem and make sure that I'm answering correctly. But if I'm not specifically answering correctly, I'm still covering the answer by doing this. 142 at x = -3. All right, that's it. I apologize for the calculator, although I didn't design the calculator, so I don't know why I'm apologizing. That's a technological issue that we had nothing to do with. But I'm gonna stop the video here. That's the end of these notes. Pretty exciting. We'll be back in the next video to look at the next set of notes. So I hope to see you there.